So, example 3, we have a similar trend here. More implicit differentiation, no big deal. But now we're asking for horizontal and vertical tangent lines. As far as I know, we've already done horizontal tangent lines. That's where you have a slope of 0. But what happens when you're looking for vertical tangent lines? First off, while I'm talking, I think I'll just go ahead and take the derivative of this because it just seems like a really good idea. I bet if we're doing something related to the slope, taking the derivative might make sense. Also, I want to point out that we might not be looking at an actual function right now. We might be looking at something that doesn't pass the vertical line test. And that's okay. Circles don't pass the vertical line test. Sideways parabolas don't either. It's not really that big of a deal. But what I would like to do is go ahead and get this derivative done. So I'll stop talking for a second and I'll take all the terms with dy dx, and I'm going to leave them on the left side of the equation, all the terms without dy dx, and I'll move them to the right-hand side of the equation. And you know what? I am almost done here. This is my derivative. And if we want to take on the horizontal, the places where we have a horizontal tangent line, that's easy enough. What we're going to do is we're going to let the slope equal 0, because that's what the slope of a horizontal line is. Now, if you didn't remember this, fractions can only be equal to 0 if the numerator equals 0. And that makes it really easy to solve for x, I think. So we know that the answer to this problem, where are we going to get a horizontal tangent line, is when x is equal to 0. But that doesn't mean that we're done with this problem. We just know that when x is equal to 0, that's where it's going to be. We don't know the actual point yet. So how do you get the point for that? Well, honestly, what you do is you go back to the original equation. X squared plus y squared minus 3y equals 4. Can you hear my cat in the background? She really wants to be part of this video. And then you solve for y, which in this case might require a little bit of factoring. No big deal. But it turns out that when x is 0, there's more than one possible y value. The only way this occurs is if you happen to have something that is not a function. And by the way, you always, to get your x or y value that you don't know, go back to the original function, something that we've done on many occasions. So I will go ahead and erase that part. We know how to get a horizontal one, so how do we find a slope that is, how do you find one that is vertical? What is the slope of something that's vertical? Well, as far as I know, that means it's undefined. But how do you show that something is undefined? That's not really a number, is it? What would make my equation undefined? I tell you what, maybe if the denominator was equal to 0. So now I know that if my y-coordinate is 3/2, I will have a vertical tangent line. The slope on my function will be a vertical tangent line. To get that number, to get the x-coordinate that's there, now I have to go back to the original function and solve it. This time I'm going to solve it when y is equal to 3/2. I actually have no idea what this number is going to be. I don't know if it's going to be a really happy one or not. But I do know that x squared is going to equal a specific number. So I got what, negative 2 1/4. How about 6.25? And I think that means x is 2.5. Brilliant. So you find the x or the y coordinates that make your slope either horizontal or vertical and plug those numbers back in